All right, let's dive in. Today we are talking about the master plan for digital defense, security architecture. Think of it as the blueprint that protects pretty much everything we do online. And we're going to build one right here from the ground up. It all starts with this massive question. When your most valuable assets are just ones and zeros, how do you actually build walls around them? And maybe even more important, how do you design a system that's both a fortress and a place where people can actually get their work done? So, to make this all make sense, we're going to use an analogy. Let's just forget about servers and networks for a second. Instead, imagine we're building a state-of-the-art corporate campus. This digital campus is going to be our guide through all of this. Every great building needs a blueprint, right? Well, in security, that blueprint is built on a few core principles. These principles dictate every single decision we make, from the big outer walls all the way down to the locks on every digital door. And this is the absolute foundation of that blueprint, the CIA triad. No, not that CIA. This is confidentiality, integrity, and availability. Confidentiality is all about keeping secrets secret. Integrity makes sure our data is legit and hasn't been messed with. And availability, well, that just guarantees that the right people can get to what they need when they need it. Pretty much every single security control we're about to talk about ties back to one of these three goals. Okay, so with our principles set, we can actually start building. Our very first line of defense is the campus perimeter. And standing at the main gate is our most important guardian, the firewall. But here's the thing. Not all firewalls are created equal. A stateless firewall is kind of like a bouncer with no memory. It checks every single packet of data against its rulebook. It's fast, sure, but it has no idea if that packet is part of a legitimate conversation that's already happening. Now, a stateful firewall is way smarter. It's more like a host at a fancy restaurant. It knows you're on the guest list, it remembers your conversation, and it lets the return traffic come right back in without making a big fuss. And this is where things get really, really sophisticated. See, while those older firewalls just see addresses and connections, the next generation firewall, or NGFW, goes way deeper. It has what we call application awareness. It doesn't just see traffic going to a certain port. It knows that traffic is from, say, Zoom or maybe Dropbox. This lets you make incredibly specific rules, like, yeah, video calls are fine, but block all file uploads. That level of control is absolutely essential for modern security. Now, some parts of our campus, like our main website, obviously have to be accessible to the public, but we can't just let anyone wander from the website server into our main offices, right? That is exactly what the DMZ is for. Think of it as a secure, isolated lobby. If a server in that DMZ gets compromised, the attacker is trapped. They're stuck in the lobby, completely unable to get to the really secure internal network behind it. Okay, so our perimeter is strong. The main gate is solid. But what if an attacker manages to get past it anyway? Well, now we need eyes and ears inside the campus. And this is where our internal guardians come into play: intrusion detection and prevention systems. First up, we've got the Intrusion Detection System, or IDS. This is basically our campus-wide network of security cameras. It sits out of band, which is just a fancy way of saying it watches a copy of the network traffic, not the live flow. If it sees something shady, it sounds an alarm, but just like a camera, it can't actually step in and stop the threat itself. Now, this is where the Intrusion Prevention System, or IPS, comes in. This isn't just a camera. This is our active guard force. It sits inline, which means all the traffic flows directly through it. It sees everything an IDS does, but when it spots a threat, it doesn't just ring a bell. It takes action. It can block malicious traffic on the spot, defending the network in real time. And that really highlights the key trade-off here. An IDS is passive. It won't slow down your network, but it relies on a human to see the alert and do something about it. An IPS, on the other hand, gives you that automated protection, but if you mess up its rules, you could accidentally block legitimate traffic. So the choice isn't really about which one is better. It's about which risk you're more comfortable with in any given situation. Of course, our campus isn't just built on our own land anymore, is it? We're all leasing space in these massive cloud skyscrapers run by providers like AWS or Azure. And this raises a really critical question. In the cloud, where does their security job end and where does ours begin? It all boils down to something called the shared responsibility model. And it's actually pretty simple. The cloud provider is responsible for the security of the cloud. That means the physical data centers, the hardware, the concrete walls. But you are always responsible for your security
in the cloud. That's your data, your configurations, and who you decide to give the keys to.
Now, how much responsibility you have changes a lot depending on the service you're using. With infrastructure as a service, or IaaS, think of it like renting a virtual server, you manage pretty much everything from the operating system on up. With platform as a service, or PaaS, the provider handles the OS for you, so you just worry about your app and data. And with software as a service, SaaS, like Gmail or Salesforce, you're mostly just managing your users and what they can access. But here's the thing. This is a massive, massive point of confusion, and the consequences can be just devastating. Get this. This statistic is staggering. It shows that most organizations flying in the cloud don't fully get where their duties begin and end. And honestly, that simple misunderstanding is one of the biggest reasons we see so many cloud breaches.
I mean, here's a classic real-world example that happens all the time. AWS makes sure its S3 storage service is incredibly secure and always available. That's their job, security of the cloud. But if you accidentally misconfigure your S3 bucket and make it totally public to the whole internet, well, that's on you. Securing what's in the cloud is always your job.
But let's be real. No matter how perfectly designed our fortress is, bad days are going to happen. A truly secure architecture isn't just about preventing attacks. It's about resilience. It's about having a rock-solid plan to get back on your feet when you get knocked down. And any good disaster recovery plan starts with two key business decisions. First, recovery time objective, or RTO. That's the question, how fast do we absolutely have to be back online? An e-commerce site might need an RTO of minutes because every second of downtime costs real money. Second is the recovery point objective, or RPO. This asks, how much data can we afford to lose? For that same e-commerce site, losing even a few seconds of transaction data is just not an option. Your answers to these two questions will dictate your entire strategy. And this is how you meet those goals. If you need a near zero RTO and RPO, you need a hot site. This is a crazy expensive, fully operational mirror of your systems, ready to take over in an instant. If you can handle a few hours of downtime, a warm site, which has hardware ready to go, is a good middle ground. And if being down for a day or two is okay, a cold site, which is basically just an empty room with power and internet, is your cheapest option. It is always a direct trade-off between how much you're willing to spend and how fast you need to recover. So, as we've seen through all this, securing a digital fortress isn't about buying one magic box or a single piece of software. It's all about layers, what we call defense in depth. It's about combining strong principles like the CIA triad with firewalls, with internal guardians like an IPS, with smart cloud security, and a solid recovery plan, all working together as a single cohesive architecture. So we've designed this amazing campus. It's got guards, cameras, reinforced walls, the works. But even the best architecture in the world can be completely undone by a single human mistake. Which leaves us with one last big question to think about. After all this technical planning, is your greatest weakness actually in the code, or is it in the people who use it?